morning, good afternoon, depending on your region, time zone. My name is Matt Robinson. I'll be talking today a little bit about what we're doing to sort of drive industrial performance in ROS-based systems, with the focus in some of the recent developments here in the ROS Industrial program here in the Americas. So next. So, I mean, I don't have to necessarily expound on what is ROS Industrial or ROS, but one of the things we've observed over time is that obviously the evolution of industrial robotics, there's been a number of different silos, or as you get very competent at a certain set of capability, you could find yourself tied to a specific vendor. And obviously, historically, the industrial robot market has been really driven, stewarded, and supported by large-scale end users. Well, we're seeing a change. You can hit next. And that change is obviously the advent of leverage of open source and, of course, the framework ROS, which brings to it a bunch of different things to the development space, including the ecosystem, which is very unique compared to those of us who cut our teeth in the industrial robotics space. Next. And then what's really interesting is as we've been tracking this data that dates back to the early 90s, is that we're actually starting to see a little bit of an uptick in robots being deployed doing other, right? So this is data from the Robotic Industries Association, where as you can see on the left, a number of the different applications were basically welding and material handling, but we are seeing a slight growth in robots being deployed to do new things. And of course, obviously look at this significant growth in handling. And a lot of that is obviously the development of advanced vision tools and processes and techniques, things like OpenCV, for instance, and things that compete with OpenCV. Next. So everyone knows, this audience should be fairly familiar with the consortium, right? We're really key on, there's so much to do in advanced robotics, and there's so much you can do within the open source community, right? So there was this idea of having some direction, and we take that very serious here in the Americas. We work with our local community and network, and of course get input from our regional partners in Europe and Asia Pacific as well. You can hit next one more time. To basically feed this sort of vision, and we have 4 verticals that we really try to hammer home. Ease of use, of course the capability, that's always the great exciting videos, interoperability, and of course human interaction, human and machine interaction. So these 4 things kind of drive us with basically feedback from the membership. And I'll touch on a few examples of some of these things here in the next slides. Next. The other thing that we've really had to give a lot of thought to was how do we move forward in a world where there's a ROS and a ROS-2. So if you hit next, and one more time. So what we've really tried to do, there was this idea of, okay, we're just going to bite the bullet, go full ROS-2. But if any of you have spent a lot of time in industry, know that, hey, if you work with Rockwell, or if you're working with Yaskawa or ABB, right, you have some level of backwards compatibility for some time. And we wanted them to live that too, right? So we went to the effort where it was very feasible and not so difficult to break out core libraries, make them basically ROS agnostic, either pure CMake or just C++ libraries, and then offer ROS-1 and ROS-2 wrappers. And this enables us to focus and deliver new capability and have them be accessible to those who are still running ROS-1 systems and those who are interested in developing ROS-2 systems. And so we've now have a little bit of our feet under us for about a year now, working with this model, and it's been pretty exciting. Next. So the key thing is, my talk is talking about some experiences getting into production, right? So our first example of that is, and Roger was great to hear him mention Bastion as well, because they've been a great partner, a member here in the Americas. But the key thing is to get that sort of integrator or people who deliver solutions engaged, right? So to educate that, like, hey, we can build an enabling foundation. Let's do that. And of course, obviously, Bastion in this particular case was the right partner. There was an end user. Bastion was the right partner to work with this end user, and we were able to come up with a plan that actually generated a proof of concept, which you can see on the left, including the GitHub repo that you can see there. And then Bastion was able to bring it to market, and from what they state is the shortest market delivery time for them, at least at that point in time. And so that was a real feather in the cap for basically what maybe we could do with ROS Industrial. And of course, the opportunities we have if we can drive into integrator and solution provider engagement. Next. So there's also, in parallel, there's been a number of basically focused technical projects. We tend to refer to them as robotic blending, but it includes, it's just an example application of a whole family of applications that we refer to as scan and plan. And you can see here the images basically show kind of like the evolution of the types of systems. And basically these programs have built onto each other, adding capability each step along the way. To the one you see on the right is very complex, and we'll talk a little bit about that. But it's been a real great foundation for production development and deployment. All right, so next. This is basically targeting, in this case, aerospace remanufacturing. This particular end user doesn't necessarily have a huge deep bench of very technical staff, right? So they don't have an army of C++ developers. And so they really needed something that that a number of the staff that are just there at their site could set up programs. In the end, they know their process, right? So we had to create some tools to lower the barrier, to enable them to basically create plans on presented material, be able to edit those plans, recall them as needed, and do some other, like say, hey, I only want to process a certain part of this plan. So be able to subsample and give them very easy, intuitive ways to navigate the system. And this also includes some other maintenance and service interfaces, such as YAML files, or basically text files that could be edited to basically update some certain system parameters, and then you rebuild, recompile, and you're up and running, right? So we now have basically created a technician and maintenance interfaces for these ROS-based systems. In this particular system here, you can see it's maybe not evident in the picture, but this wing in this case has just been rolled in to the work volume, and the robot basically finds it, says like, hey, I've got this object. The operator matches it to something in their database, kind of drags it over like game style. It snaps into place, and then they can apply the various mix of processes that they've saved. And of course, it goes through various localizations, and they can use a menu of localizations to improve the localization score. And once they're happy and everything looks pretty good, they hit go and they can just observe. So this has been a really great success. 3 of these style of systems have been deployed. I think the oldest has been in production for nearly a year now. So it's a really exciting success story. That process head you see there has 7 different processes on it that they can call on demand. Next. So of course, obviously there's a number of different libraries we leverage. These are common in ROS Industrial or the ROS Industrial Consortium repositories, ROS SCXML. It's becoming a standard here in the Americas for how we build state machines. So it's a very useful way to build the state machine, and a way to sort of map it out, lay it out, edit it, and it's basically just updating an XML file. So it's a very useful standard to develop to for state machine management. The other is YAC. It's a reconstruction algorithm. There's a sample of a reconstruction of a machined aluminum part there on the left. It's really great for very shiny surfaces that can play havoc with single shot perception cameras. So it's a reconstruction technique that takes advantage of the TSDF algorithm, and we have an open source implementation in ROS Industrial. We also leverage it not just for full reconstructions, but for localization. And that's what we did in this particular case. Nether is for raster path planning. That's the output you see on the right. And Tesseract in this particular case was the motion planning environment, which includes a hybrid version of Descartes, a number of other kinematic solvers, as well as a number of environmental elements as well. Next. So obviously the key takeaways were a lot of the lessons learned. The nice thing is we're leveraging a lot of the optimization-based path planning, and the key element of that is coming up with the techniques to generate the appropriate cost functions to make sure when you put a complex end effector with lots of cable management on your manipulator, like how do I account for that? Well, everything in optimization is really just a cost, right? So we are able to basically account for all the restrictions on the manipulator as this costs in the optimization function. So that really helped, right? So we were able to actually account for limitations on the physical configuration of the manipulator. Hey, where are no-go zones with the external axes? In this case, it's there's 2 additional axes in the one pictured, as well as accounting for all the festooning and cable carriers and other restrictions that complex EOAT presented, as well as other different techniques for doing dynamic error recovery. So it was a lot of interesting lessons learned that we're actually incorporating and putting some other additional features into the open source tools to account for this. Next. So a step further, that was a lot of ROS-1 work. Around the same time, we launched a ROS-2 application. We wrote a blog post about it. It's up over on rosindustrial.org. We refer to it as Project Alpha. While we can't necessarily speak about the project in very deep specifics, we wanted to share a lot of the improvements we made to our open source contributions based on this work, right? So, and of course, our learning with the best way to implement ROS-2, in particular in a state right now where we still don't have a lot of interfaces, in particular for manipulators. In this case, we were working with the UR10E with the ROS bridge. So how to optimize the performance of the ROS bridge was really key. And you can see here, we make note of that as well. Next. So, as you note here, there's a bunch of different porting that took place. So hence now we have Tesseract, for instance, and ROS-2, which has really been enabling. There's been a bunch of different improvements made to the packages to support either both ROS-1 and ROS-2 or create specific variants for ROS-1 or ROS-2. We also did had a chance to do a fair amount of benchmarking of a number of BDS implementations, to the point where we actually make some notations in the blog, at least relative to that specific application, what worked best. On the right here, you can see pictured a demonstration system that's similar to the mobile robotic platform that we developed for the end client. And we're going to be demoing, we've demonstrated this a little bit to a degree at our recent it feels recent still, but the ROS-Industrial Americas meeting in March. And of course, while hopefully, assuming we can have it in person, we'll take it to Detroit at Automate 2020 with some new additional features and performance improvements. Next. So following on to that first ROS-2 project was one we were able to do a little bit more collaboratively and in the open. What's interesting about this particular project, it was funded by a collaboration of the Manufacturing Innovation Institute, the ARM Institute, which is Department of Defense and industry collaborative seeking to advance robotics for both industry and, of course, government activity. Here we were working with Spirit Aerosystems and Wichita State University, and we set this project up intentionally to do it fully developed in the open source, right? And it included some work on force commanded constant velocity trajectory controller, and as well as some response to human markings to do rework. Next. So obviously the nice thing was with having an end user already pulled in, they had a real nice use case. So they do a lot of sanding of composite components. They had done some implementations with robots in the past, but they've been heavy industrial robots, and they wanted something where the people could like do detailed work while robots are just doing the kind of bulk work. Next. So one of the other things that we've really adopted is leveraging either Ignition or Gazebo in the development. This has been really nice because it really helps us to test a lot of the functionality with the sensors and enable us to test then localization, sensor-based localization. So this has been a really handy tool, particularly as we got into some other details with some of the free space motion planning. And just richer visualizations for communication tools and proof of concept and understanding kind of some trade-offs as we went through the design process with the university team. So that's been a new practice that we've adopted. It's been really handy. Next. It's one of the new capabilities we wove in here and ported to ROS-2 as well, because some of you, well, maybe no one really recalls that ROSCON, so much information, it's hard to remember necessarily something was presented at ROSCON, but this is a sub package called Reachability. And what's really interesting about this is you can see in the far left, those dark blue dots, might be hard to make out, but there's these dark blue dots on that presented part. And that's those are the waypoint trajectories, right? Loaded toolpaths. On the right, you can start making out like, hey, I've got some light blue dots. Oh, those are unreachable. And then here, where we have green, those have planned successfully. And the yellow are not full strokes, so they've been eliminated. And then failed are red, and that's due to collision. And this is a really handy quick eye check. In this particular system, I can actually manually reposition the base. In certain cases, in future configurations, there will be 2 robots up there, the movable, positionable bases. So you can get a real quick visual on, hey, the part's either not presented optimally, or I should adjust the base position of the robot, and it gives you kind of a visual cue of what that trade-off is. And that's been kind of a real handy tool, and it's woven into this application. Next. The other work is like, in this particular case, they didn't want to include any kind of force control. They're like, it's been marketed that the UR10E already has incorporated force control. So let's not add any additional compliance in the sanding. Let's do constant force, like, hey, I'm going to apply 10 newtons. You have to move at 50 centimeters a second. Go. And just put a sander hard mounted on the end of the faceplate and make it work. So we leveraged an FZI developed compliance controller and added the ability to do constant force and constant velocity trajectories. So basically created an action server that did some like sort of forward forecasting to do the curve following, and that's kind of some of the testing you see there in the video. So, and we have made this sort of available as well, and there's, I believe, a blog post already up there on some of this work. Next. The next piece was, there was a lot of interest because this is going to be a collaborative application. Since you have a human operator doing very detailed work, when the robot finishes some execution of trajectories, the operator can just go over and annotate, like, hey, not acceptable, draw arbitrary shapes, and as long as it's enclosed, that was the only rule we had, we would actually then plan trajectories inside those human markings. And here you can see, we created two halves to show the ability that, like, hey, the drawing doesn't have to be completely in one snapshot, so to speak, and we can pick it up and stitch it together and fit it to the 3D data. And that's what we did here. Next. So here is the integrated solution at the Wichita State Aerospace Lab. That's actually a representative Spirit part, but that is a composite part on a mold that supports the part. And so here we're doing force control commanded trajectories and basically have just rolled the part in, localized it, and then applied the tool pass. And of course, we're running the as specified forces and trajectories. There will be a newer, much, let's just say, nicer video forthcoming. It's actually already circulating. I just didn't have approval to share it for this particular meeting, but we'll actually showcase both the force response and how well we track the force, and as well as the human response to the human marking. Next. So a couple other things that have come out. This is real-time path planning. So we had the thought that, like, hey, we could probably really accelerate our ability to respond to dynamism in the environment if we did things like, say, leverage GPU when they're available. It turned out, actually, we just reconfigured how we're doing the optimization problem. And we demonstrated, and there's a huge write-up over on the ROS-Industrial blog, I won't belabor it, but basically we can run this sort of dynamic response at greater than 200 hertz. And it looks really feasible to avoid certain level of dynamism in your environment, up to and including, in this particular case, avoiding a person entering this gantry cell. So we're really excited to find some opportunities to test this. We have some systems that have sort of the capability to dynamically monitor their environment. And there's plenty of cases where it's a non-human thing we want to potentially avoid, which is probably where we would start. But the fact that this is sort of dynamic optimization is really interesting. Also, we've just released a Tesseract setup wizard. It's being deployed via Snap package. I've included the link there. We're really looking forward to testing from an ease of use perspective, delivering capability by Snap, because it comes with all the dependencies. You can just grab it, you install it, and i.e. it just hopefully works. Right, so that's the goal, and that's lowering that barrier to entry for the manufacturing engineers who are tasked with getting parts on cells or getting systems set up that don't necessarily have the complex CS background to really do a bunch of system configuration. Next. And that's a picture of the setup wizard. Next. So what are we trying to do, right? I touched on the Snap package and what we're going for with the setup wizard. We actually had a recent person actually test the setup wizard, grab the Snap, and they had a couple issues with the visualization side of the configuration wizard, but overall we're very pleased with the configuration wizard, and it generally worked pretty well. get the visualization component working. They did have to build from source, but we're getting that resolved, and we'll update the snap shortly. But that's the example of what we mean by grab and go, right? We would love to get to the point, and obviously we're working closely with Eric and his team there in Singapore and our friends at Fraunhofer IPA to do what we can to get these sort of repositories, assess their quality, understand where they are, make sure they're properly maintained, and obviously work with our membership where hopefully they see the value and also testing these and where it makes sense to push improvements and fixes back to them. The other things we're always interested in is being cross-platform. So we're currently right now doing a bunch of build testing and actual performance testing on Windows systems. This particular picture here, we'll be doing a bunch of work with the HoloLens 2 to enable operators to kind of come and do annotation, sort of an augmented reality, and the system responds to it and does more detailed processing. So we hope to be demonstrating and reporting a little bit more on like, hey, how are these cross-platform systems really performing? That drives into, of course, obviously this assured quality and performance, right? Which is, again, all of our regions are working towards this in concert. As I said, a little bit more of a focus for us has been this sort of non-expert application setup. Kind of touched on it. That's kind of the whole wizard goal. So we're looking for more people to get their hands into it and see if this delivery vehicle really helps to get them up and going. And the menu-driven interaction with ROS-based systems is helpful. We're also very excited in this idea of the solution developer to end user. So the real success story for us of the system you see here on the screen, it was integrator deployed, right? And this integrator now feels fairly comfortable in certain circles saying like, hey, we deliver ROS-based systems. It is something we can do, we're comfortable with it, right? And so end users get more value when we have a capable set of solution providers that feel confident that they can deliver these solutions, and they have support, be it with working with partners like with Roger and his team, or of course our consortium organizations, or other folks who are leveraging or offering solutions that work nice with ROS or are fully open source. Next. So anyways, one of the big things, hey, ROS-based systems, they're delivering value today, and they have been for a while now, right? So if you are on the fence about like, hey, is a ROS-based solution right for me? Is it supported? Go for it. ROS-2 also ready, right? So if you haven't really gotten started, go ROS-2. Right, the only little hang up is this interface, but then we're here to help you communicate with OEMs, express your interest in ROS-2 interfaces for hardware. That's the whole point of the consortium, right? Is we work together to kind of knock down some of these barriers. There are development partners to help you deploy these advanced systems. So if you're an end user and you don't feel like you have a lot of support, you don't have the internal team, there are folks out there who can help you get deployed. And of course, obviously, we're really big on the building blocks. Like, while we'll obviously create complete solution examples, the key is that we have the building blocks to really enable you to build what you want to do, whether it be it working with a solution provider or on your own. And as a community, obviously, we really want resources to focus on what makes a difference for each end user, right? So again, we work together to enable the success of all the different end users out there. And I think if we remember that, right, there's a lot of big things we can do. Next. So again, I just like to close with a number of resources here. I'm sure Eric and the team there at Asia Pacific makes these available. We'll have a lot of similar ones from them too, but these are sometimes helpful. And then with that, thank you for having me, Eric. Thanks for inviting me, and the Asia Pacific team for hosting me. Always enjoy working with ARTC and the ROS-Industrial Asia Pacific team. Thanks, everybody.